I am in your textbook on page 397. So you should put these notes in your journal or in your textbook. On page 397, they give you the steps for solving a cubic. We're only looking at the easiest kind of cubic to solve. It's appropriate for an Algebra 2 course. There are some other cubics that would require a lot more algebra. We'll save those for higher level courses. So the kind of cubics that we're going to solve are the kind where we just have one radical, and underneath the radical is our x. We have no other radicals located in the problem, and so these will be the steps that we have to go through. They should look familiar, because with the exception of this word cube right here, they are the exact same steps that we did for solving square roots. So isolate the radical. That means that I am going to wait patiently for my program to change. Isolate the radical. So the radical and anything under it needs to be by itself. So what do I need to get rid of? I need to get rid of the 4, and I need to get rid of the -5, and I have to do it in the correct order. Remember, when we undo things, we go in the opposite order in which we would do them if we had an x. So if we had an x, we would multiply by a 2, then we would subtract 1, then we would take the cube root of it, then we would multiply that times 4, then we would subtract 5. Since subtracting 5 is the last thing that we would do, it's going to be the first thing that we undo. So I'm going to undo that subtract 5 by adding 5 to both sides. So that's going to leave me 4 times the cube root of 2x minus 1. The 5's add to 0, and I end up with 8 on this side. Now I've got to undo the 4. That reads 4 times the cube root. How do I undo times? I divide both sides by 4. Those 4's divide out, leaving me my cube root. 8 divided by 4 is 2. So I've isolated the radical term. Now the only thing on the left side of this equal sign here is the radical term. I need to make the radical go away. So I do the opposite of taking the cube root, which means I need to cube both sides. Now the cube root and the cube will cause each other to undo each other, so we carefully use the word cancel. And then 2 to the 3rd power is 8. Now we just so we finished step number 2. We've cubed both sides, and that leaves us to solve for x. Complete solving for x. So what is happening to x? We're multiplying it by 2, then we're subtracting 1. Since subtracting 1 is the last thing we would do if we knew x, adding 1, the 1 is the first thing we're going to get rid of, and the opposite of subtracting 1 is to add 1. 2x equals 9. 8 plus 1 is 9. Divide both sides by 2, and we get x is equal to 9/2. You can leave it 9/2, or since it's a terminating decimal, 4.5, you can put it as 4.5. Don't forget, you can use the TI Inspire calculator to find the solution as well. Finding the solution on the calculator will allow you to check to make sure that your answer is right. We're going to check it 2 ways. The first way we're going to check it is by finding the intersection. So as you can see right here, I got a graphs page, and on the graphs page on the function 1 line, I typed in everything that I saw on the left side of that equal sign. I typed that in. Then I went to the second line, F2, and I typed what I saw on the second line. That's why it graphed the 2 things. The blue line is the first equation that I graphed, the cube root equation, and then the second one is the red one, and I'm going to find now where they intersect. That's where I'm going to find the solution. And you find that by pressing Menu, Analyze the Graph, and find the intersection. And they want to know the intersection of what? So the lower bound, they simply just mean which equation are you wanting to find the intersection of. So lower bound means get on the left side, so I'm on the left side. And now upper bound means get on the right side. As you notice, as I moved it to the right, it found an ordered pair for me right there. Now, how many variables did this equation have in it? It had one. It had an x. So which one are we looking at over here? We're looking at that 4.5, which is exactly what 9/2 is. The y value is where the the y value at where the intersection happens, but I'm not interested in the y value. I'm only interested in the x value. Now, as long as you have this function graphed or entered on the graphs page, you can go back to a calculator page and you can plug that 4.5 or the 9/2 in for x. Remember, it's on the function 1 line. So if you just type in f1, then it knows that you're talking about the function 1, and that's where our x is. So you're going to open parentheses and you're going to type in, you can do 9/2. And it's going to plug it in and chug it out, and on the left hand side, when you plug in 9/2, this side calculates to give you 3. So we end up with 3 equals 3, which is a true statement. So that's another way that you can check your answer. It doesn't matter if the problem is written with a 1/3 rather than a radical. If you don't like working with the 1/3, then simply rewrite it as a radical. The steps will be the same. I have to isolate the stuff that is raised to that 1/3 power. That's the same thing as saying isolate the radical. So what do I need to get rid of? I need to get rid of the 4. And the 4 is being added not because of this plus sign right here, but because the 4 is a positive number, because it doesn't have a negative. So we're going to do the opposite of that minus, and by minusing 4 from both sides, that's going to leave me x minus 1 raised to the 1/3. And that's going to be equal to -2. Now, how do we make this 1/3 go away? We raise it to the reciprocal. It's the same thing as saying cube both sides. That's the cube root. The 1/3 right there is the cube root. So the inverse operation of taking the cube root is to cube it. So what we do to one side, we have to do to the other. That's why it works the exact same way. These two cancel each other out, and we're left with x minus 1 equals -2 times -2 times -2 ends up being -8. We're at a point now to where we finished. What do? We isolated the radical when we subtracted 4. We cubed both sides, and now we're solving for the unknown. So we're going to say, what's the opposite of -1? We're going to do +1 to both sides. And x equals -7. We're going to go to the calculator and check that real quick. And of course, you can also use Desmos to check your work. I put the left side on one line. I didn't put the y equals, but it's not a bad idea to always put y equals, simply because you have to put the y equals whenever you're putting in the constant. So just remember to put y equals. Left side, put y equals, and then the right side of the equation, and then Desmos always marks the spot where they intersect with an ordered pair, a coordinate, a point, and if you just hover over that point, it shows you that the x value is -7. I don't care what the y value is, because in the problem I was just asked to find the x value.